Today we will discuss thermodynamic process. What is thermodynamic process? There are different types of thermodynamics. First, we will discuss constant volume process. Constant volume process, also called isochoric process. When the gas is heated at a constant volume, its temperature and pressure will be increased. Since there is no change in its volume, no external work is done by the gas. We know that work done is equal to PdV, but here change in volume is equal to 0, so work done is equal to 0. Now we will find heat supplied. So Q is equal to WU plus W. So Q is equal to WU plus W. What is W? Change in internal energy, but here work done is equal to 0, so heat transfer is equal to heat supplied is equal to change in internal energy. We can say that another way, Q is equal to change in internal energy, the U2 minus U1 is equal to mCV dt. This is the diagram. This is the pressure, this is PV diagram. Here the change in only volume, so it is only straight lines. Okay, now we will discuss the second point, constant pressure. It's also called isobaric process. When the gas is heated at a constant pressure, its temperature and volume will increase. We know that W is equal to PdV, so change in volume V1 is V2. Let's see the PV diagram. This is the change in volume from 1 to 2, V1, V2. So here PV is a P2. Here P is a constant, so outside, so W is equal to V2 minus V1. Okay, we know heat supplied, Q is equal to change in internal energy plus work supplied. What is the work done? Here we can find, so Q is equal to change in internal energy, U2 minus U1 plus P, V2 minus V1. Okay, let's see. Q is equal to du plus PdV. Change the du, we can say that PdV. Here d is outside, common, then U plus PV. We know U is equal to enthalpy, so U plus PV is equal to H, so Q is equal to dH. We know change in enthalpy is equal to CP dt, so Q is equal to CP dt. Okay, now here some important point is there. When the gas is cooled at constant pressure, there will be compression. The temperature and volume will decrease during cooling and work is said to be done on the gas. Now how can I find heat rejected by the gas? The formula is there. Q is equal to mCp T1 minus T2 या फिर mCp dt. Then decrease in internal energy, U2 minus U1 is equal to mCv T1 minus T2, and we can find work done W is equal to P, V2 minus V1 या M or T1 minus T2. Second point is here, during expansion or heating process, work is done by the gas or system. If work is done by the system is positive, if your work is done on the system is negative. That's all. Thank you.